This is the start of Unit 2, which goes over logic. So the first section that we're going to look at in the logic unit is statements and quantifiers. So let's go ahead and check out 2.1. So the first thing we have to do before we determine if arguments are valid or not valid is we have to understand what a statement is. So in this section, we're going to talk about simple statements, quantified statements, and negations. So for starters, a statement is an expression that is either true or false. So we can prove whatever the statement is, and if it's true, it's a statement. If it's false, it's a statement. So here are some examples that we are to look at to figure out if there are statements or not. So the first one is, today is Monday. That can be proven to be either true or false. So yes, it is a statement. All birds can sing. Again, we can prove that to be either true or false, so yes, it is a statement. According to the FDA, calorie labels on food can be up to 20% inaccurate. By the way, that's a true statement, and the answer is yes. Are we there yet? It is a question. So questions are not statements. So the answer to that one is no. The Bucks are the best team. Again, that is an opinion. Opinion cannot be proven to be either true or false, so therefore the answer is no. Clean your room. Well, that is a statement or a command. It's not a statement, it's a command. So the answer is no. That can't be proven to be either true or false. This statement is false. Well, this one's tricky because it's a paradox. Is it true? If the statement is true, then the statement is false, etc. So I'm going to put no on that one, and we're going to move forward. Okay, so the negation of a simple statement has the opposite truth value of the original statement. Negations are commonly formed by adding or removing the word not or no. So write a negation of the statement. I made an A on my math test. So the negation of that would be, I did not make an A on my math test. So again, negation makes the simple statement have the opposite value. The frog is not green. So the negation of that would be, the frog is green. Dua Lipa is a singer. Dua Lipa is not a singer. If the statement is true, then its negative is false. Okay? So we talked about statements being either true or false. So if I take the negation of a statement that is true, it becomes false. And if I take a negation of a statement that is false, it will become true. So now we're going to look at special instances where, it's kind of like an all or nothing. For instance, we're going to look at the statement, all vegetables are green. Most of you would say the negation of that would be no vegetables are green. However, that is false. So let's see why and let's see what the rules are. So first of all, there are two types of quantifiers we're going to be looking at, one of which is a universal quantifier and the other one is an existential quantifier. A universal quantifier states that the entire set of things share a characteristic. The characteristics are all, every, or none. So universal means the universal amount of things. So it's all encompassing, okay? An existential quantifier states that the set contains at least one element, possibly many, some, at least one, or there exists. So existential quantifiers are not every single one, it's some of them, or at least one of them. So that's the difference between universal and existential. All right, all whales are dolphins, that would be a universal quantifier. There exists at least one odd prime number, there exists at least one, that wording makes it existential. Some Spanish words are the same in English. Again, existential. Example, assume the statement all of my children are males is true, that I have 3 children. So we're going to label the statements are either true or false based on this. All of my children are males. So the only time that's true is when you get boy, boy, boy. When you have boy, boy, girl, it is false. Boy, girl, girl is also false. Girl, girl, girl is false. So which of these negations of all my children are males? So if you look at it, everything's false with exception of every single one, right? So we have to write up all as this. Some of my children are not males. And that would take care of all of these 3 scenarios. Okay? So the negation of an existential quantifier is a universal quantifier and vice versa. So if we look at this chart, the negation of all, which is a universal quantifier, is some are not. So if we look at this diagonal, that's what we're concerned about. The negation of none is some are. So negation of none, which is a universal quantifier, gives us an existential quantifier as some are. And vice versa. If we're going to negate some are, we're going to get none. If we're going to negate some are not, we're going to get all. So write the negation of these statements. Some math teachers are nice. So we have an existential quantifier that we have to negate. So the negation of some are none. So no math teacher is nice. I hope you guys don't feel that way. The next one, no muffins are fat-free. So the no is a universal quantifier, and the negation of that is some muffins are fat-free. Next one, some pigs can fly. Again, that is an existential quantifier. So negation of that will give us a universal one. So the negation of some is no. So no pigs can fly. Every function is continuous. Every is the same as saying as all, and the negation of all is some are not. So some functions are not continuous. Whoops, there we go. Some rules do not make sense. Again, that is an existential quantifier. So we have to use a universal one. So some are not, the negation of that is all. So all rules make sense. Okay, so again, with the universal and existential quantifiers, the negation of all is some are not. The negation of none is some are. Okay, so thanks for watching the first, or actually we're done with this whole entire video. So continue on and watch 2.2. Thanks for watching.